In this video, we want to find out the inverse of a quadratic function. First of all, we know the basic functions for finding the inverse of a quadratic function. Inverse of a quadratic function requires the reverse of the original function. Whatever the function is given, we must reverse that original function and we will get the inverse of this function. Undoes what original function has done. Also, domain will become the range of f inverse of x, and the range of f of x will become the domain of f inverse of x. X coordinate will become the y coordinate of f inverse, and the y coordinate of f of x will become the x coordinate of f inverse. For example, we have a coordinate point 4, 2. This coordinate point will be converted into 2, 4 for f inverse of x. The x coordinate will become the y coordinate and the y coordinate will become x coordinate. Quadratic function or the equation are the equations of the form ax square plus bx plus c, where a, b and c are the constants. Also, another form of the quadratic equation is the vertex form of quadratic equation, that is f of x equals to a x minus h whole square plus k, where h and k makes up the vertex of the quadratic equation or the parabola. Consider the graph of f of x equals to x square. This graph is parabolic in shape because this equation is in the quadratic equation form. In order to find out its inverse, we will switch the x and y coordinates. For example, 2, 4 coordinate will be switched as 4, 2. X coordinate will become the y and the y coordinate will become x. Input values will become the output. Also, the most important thing that we must follow, that graph of inverse will be the reflection of original function about the line y equals to x. Consider the graph f of x equals to x square that is shown by black color line, and y is equals to x is the line that shows the reflection of f of x about y equals to x, this line. Now this f of x equals to x square, if we want to find out its f inverse of x graphically, the x coordinate of this x square will become the y coordinates of f inverse of x, and the y coordinates will become the x coordinate of f inverse of x. So the graph for f inverse of x will become like this. When we talk about the domain and range of f of x, the domain of f of x is basically the set of all real values, and the range of f of x is basically y. The values for y will give us the range of f of x, and the values for y are basically y greater or equals to 0. So range of f of x is y belonging to set of real numbers such that y must be greater or equals to 0. Now, if we want to write down the domain and range for f inverse of x, simply we will switch both the domain and range for f inverse of x. The domain will become the range for f inverse of x, and range will become the domain for f inverse of x. That is, domain of f inverse of x, that will be basically the range of f of x. That is y belonging to R such that y must be greater or equals to 0. And the range for f of inverse will be x belonging to R. Now, if we want to check whether this f inverse of x is a function or not, we will just follow the vertical line test. In order to find out that whether f inverse of x is a function or not, we will just follow the vertical line test. We can see this graph for f inverse of x. We will just draw the vertical line through it anywhere on the parabola. We can see that this vertical line cuts the graph of f inverse of x at most 2 points. If this vertical line cuts the graph at 2 points, that this shows that f inverse of x for x square is not a function. So mostly f inverse of x for the quadratic function is not a function because the vertical line will cut the graph at most 2 points. So we can make it a function by restricting its domain. For example, if we restrict its domain, then it will become a function. Now consider the example y equals to 2 into x plus 3 whole square minus 4. First of all, for finding the f inverse of x, we must draw its graph. Its vertex will be, just by comparing this equation with the vertex form of equation, we will get h equals to 3 minus 3 and y equals to minus 4. So its vertex will be minus 3 minus 4. Now for drawing the graph for f inverse of x, the vertex for f inverse of x will become, since the vertex for f of x is minus 3 minus 4, so vertex for f inverse of x will become minus 4 minus 3, that is reverse of this coordinate point. So basically minus 4 and minus 3. Here is the point minus 4 and this is the point minus 3. So here it is the vertex for f inverse of x. So its graph will be like this. This is the graph for f inverse of x. Now if we want to find out the f inverse of x algebraically, consider the equation for f of x. Since we know that f of x equals to y, so we replaced f of x with y. After replacing f of x with y, switch the coordinates. We will write x in place of y and y in place of x. X in place of y and y in place of x. Now we will undo the operations. Since minus 4 is subtracted, so here it will be added. Now 2 is multiplied with this side, here it will be divided. Now to undo this operation of square, we will just apply plus minus square root and we will get y plus 3. So we will get minus 3 plus minus x plus 4 over 2 equals to y. So basically this y is now f inverse of x, that is minus 3 plus minus under root x plus 4 over 2. Since f inverse of x is not a function, because if we draw a vertical line, we will get the 2 points where this vertical line is touching. So this is not a function. So I could not write f inverse of x for y, since the inverse is not a function. But if I restrict the original domain, to x is greater or equals to minus 3, then I can say that I can write it in the function notation, and it will be f inverse of x equal minus 3 plus x plus 4 over 2.